Welcome to Field Notes, the monthly podcast of modern steel construction, the monthly magazine of AISC. I'm your host, Jeff Weisenberger, editor and publisher of Modern Steel Construction, and this month's guest is Ryan Sherman, an assistant professor at Georgia Tech's School of Civil and Environmental Engineering, where he's worked since 2019. He's also this year's AISC Milik Fellowship recipient. Named for William A. Milik Jr., a former AISC Vice President of Engineering and Research, the four-year $50,000 per year award is presented annually to a promising non-tenured university faculty member. So thank you for taking the time to chat with me, Ryan.
Thanks, Jeff. I really appreciate being here.
Excellent. So, I always like to start from the beginning. So maybe can you tell me, where are you from and where did you grow up?
Absolutely. I'm born and raised in Appleton, Wisconsin. Actually, my parents still live in the same house that I came home to as a baby when I was born. So grew up there, lived there till I was 18, and then off to college, I went up to Michigan Tech.
Okay. Oh, very good. Yeah. So you, instead of, Appleton's pretty far up there. Instead of coming further south, you actually went even further north to go to college.
Yeah, I debated between UW-Madison, which is an excellent program as well, and Michigan Tech. Michigan Tech going to Ski Hill though, so that was pretty attractive, and I really liked the hands-on nature of their program up there. That you really got in, you were an engineer from day one, and it just kind of resonated with kind of how I had been brought up at that point in time.
Oh, that's excellent. Yeah, no, that's great to hear. I have heard of that Ski Hill. Is that in Marquette?
Well, there's one in Marquette. There's actually one right, I guess it's in Hancock, across the portage from Houghton, but Mount Ripley. And then if you go further north, there's Mount Bohemia. But the one the school owns is Mount Ripley. And it's not huge, but what's nice about it is, right, all students need a relaxing break. And, you could jump over there, go ski for an hour, and then go back and get back to your studies and have a nice relaxation, mind-clearing time after a long day of classes.
And I have to ask, growing up in Wisconsin, are you a lifelong and also diehard Packers fan?
Yeah, you kind of have to be, right? You at an early age, you bring it in, and I have a 2-year-old and a 5-year-old now, and I still have to try to instill that in them, even though we're in Atlanta now, and obviously a lot of their friends are Falcons, or there's a lot of transplants here, a lot of fans from other areas. I still have to try to get them to be Packer fans. Right.
But yeah, I was going to say Packer fans you can sort of find everywhere. So you went to school up north, and so what made you take that path in the first place, I suppose? How did you first become interested in buildings and the path of engineering?
That's a great question. I think you can give the cliche answer that everyone has is, right, you grew up with Legos and you were building stuff, Lincoln Logs and all the kids' toys. But I really came from a family that had a lot of people involved in the trades, the construction industry. Okay. So growing up, it wasn't uncommon that we'd be putting a roof on a house one weekend or building a shed. My neighbor actually was my first employer, and he owned a metal shop. And we built trailers and other metal products. And I probably started there maybe even before I was in high school. Something simple like cutting the grass or sweeping the floor and helping them out.
Sure.
And it just kind of continued, and you start learning to get more and more skills and start grinding and then welding, and eventually you're doing everything in the shop. So I think that probably helped solidify it. I was also good at engineering in terms of like the math and physics skills in school. Mm-hmm. So when it came time to kind of select a career path, it kind of all came together and it made sense.
Well, and it's also great to hear that, besides, going into engineering itself, you had a background and you have an appreciation for the hands-on part of things as well. I mean, welding and such.
Oh, absolutely. I think that's made a huge impact on the career path that I've chosen and kind of the choices I've made as I've continued through that career, as I've gotten into engineering. Neither of my parents have college degrees, but most of my uncles like I said, been involved in the construction industry. My brothers, one of them is a construction manager, the other one's a journeyman pipe fitter. And I think that's definitely helped influence as I've continued on. I got to Michigan Tech, and AISC has a great steel bridge program, right?
Yes.
In terms of student competition, that was something that resonated, having that skill set from learning how to weld and grind through those high school jobs. That was a natural fit, and I think it's then progressed to where I'm at today as well.
Well, excellent. And so, yeah, and I know you're a professor now, and I was going to ask, did you, before getting into academia, were you a practicing engineer at one point?
I didn't really go into true practicing engineers. I had a few internships along the way. Between my master's and my PhD, I had the opportunity to work as a research engineer. So it was still in the academic setting, but definitely more project management responsibilities, leading more projects. In your master's or your PhD, you're typically working on one project. So I had that opportunity, but never in a design firm full-time beyond an internship.
Okay, gotcha. Well, speaking of getting in your master's and PhD, what put you on that career path to wanting to be a professor?
I feel like it naturally kind of progressed. I mean, if you ask my parents, they'd probably just tell you I was a lifelong student, never wanted to leave school. But after I finished my BS, I knew I didn't know enough to really be the structural engineer I wanted to be, to work on the challenging, complex problems. So I sought grad schools, and I was fortunate enough to get into Purdue and get funding to be able to work on a research project with Rob Connor. And I finished up the 1.5 to 2 year master's, and I still wasn't quite sure what I wanted to do. But my now wife actually had about a year left in her graduate degree at another school up in Milwaukee, Wisconsin. And I don't know if Rob was playing the long game or what, but he offered me this opportunity to be a research engineer to help start a field monitoring program. He previously had one when he was at Lehigh before he moved to Purdue, and he wanted to get that kind of off the ground at Purdue. And I just had to, stay with him a year, and that worked out well at the timing with my now wife. And, she applied all over the country. She's a biomedical engineer, and there's, I'd say, less areas where they can go versus a structural engineer. So I was like, I'll find a job. She applied all over the country, gets one job in West Lafayette, Indiana. So she moved down, we were married. I continued on the research engineer thing another year. And at that time, I was working with students. I enjoyed it. I enjoyed the research. And it was like, I'm at this great institution. Why don't I get my PhD? Didn't have any intention of being faculty at that time. And then I think over the course of the next 5 years, you just grow to love it more and more, and being in the research, being involved in the engineering community, and working with students, right? Because we typically have undergrads and stuff, that it just kind of naturally progressed in that direction.
Well, that's great to hear. Speaking of working with students, I mean, you got to do that as a research engineer, but I have to ask, what was it like? Can you recall, your experience, your feelings that first time you stepped into a classroom as the professor in a classroom setting?
Yeah, it's certainly a nerve-wracking experience. It's one thing to be in the class and to take notes and listen, and now suddenly you need to be the one in the front teaching. I certainly had a lot of help, a lot of support, a lot of mentorship from other great faculty, whether it was sharing notes. AISC put on entry-level teaching your first steel design class, an introductory steel class. Those sorts of activities helped, but it was nervous and at the same time exciting. So I tried to bring a lot of energy, and I was obviously excited to be there. And I think that resonates back to the students, right? If the faculty is excited about what they're teaching, they get excited, and we can bring them along as being good structural engineers, or maybe they're undecided. My first class was mechanics and materials, right? It's like our introductory course. Everyone's kind of got to take it. But at that time, a lot of our civil engineering students don't know what path they want to go down in terms of the civil subdisciplines. But, if we can get them excited about what they're learning in that class and how that relates to structural engineering and the cool buildings and bridges and everything they can design long-term, we can really then attract our students in that direction. So I don't know if that directly answers the question, but it was nerve-wracking and exciting all at the same time.
No, that's great. That definitely answers it. And I think it's a great point. When you're excited about things, they're going to get excited about it too. If you're droning, if you're one of those infamous droning monotone professors, maybe that doesn't have the same effect on students. Maybe it's more of a chore at that point.
Yeah.
Switching over to the research side of things, I want to talk a little bit about additive manufacturing, because I know that's one of the reasons, if not the reason, you were the MILEC recipient this year, was for your research in additive manufacturing. Can you talk a little bit about that and what got you interested in that area or that topic?
Yeah, so I first saw, as you've probably seen and everyone's seen by now, the bridge by MX3D in the Netherlands. And
Yes.
I heard of that project coming on. It wasn't finished by any stretch of the imagination. When I first saw it, I was like, this is really cool. And given the background that I had with welding and fabrication and the work that I did with my graduate degrees, I'm like, this is a really cool technology. Also, at the same time, being a young early faculty, I mean, this was in my first or second year being a faculty, we need to start to carve out where we see things going in the future and what areas we can dive into and learn more about that maybe we can start to make a career toward. And I just saw that as something that was coming down the pipeline. You saw additive manufacturing outside of steel in other industries really taking off.
Right.
But I really thought it could be a tool that the steel industry could leverage to, be better, right? Put another tool in the toolbox, give us more capabilities, help us stay competitive. And that's kind of how it started. I wrote a couple of proposals early on, had mixed reactions, right? Sometimes people are a little questionable at first of new technology and where's this going and how's this taking off. And then you saw other groups like Lincoln Electric has their additive solutions center now where they're a service provider. And when you start to see big name people in the industry make investments like that and invest in the technology, I think it certainly helped start to push things forward. And then I was fortunate enough to get a project from Federal Highway Administration. They were interested in it. And now I'm honored to have received the fellowship because it's going to help push things forward even more.
Excellent. That's good. And I guess, so when it comes to additive manufacturing, like you were saying, other industries have done it, and I've seen it, done with metals when it comes to small components. But could you talk a little bit about, I guess, kind of what it would look like for actual structural projects? I mean, maybe you could talk a little bit about the bridge in Amsterdam. I've seen it. I've seen pictures of it. I've never actually seen it in person, but just how did that come to be? Can you talk a little bit about the construction of that, and then also maybe about maybe go into a little bit of detail on your project with the Federal Highway Administration?
Absolutely. So the bridge in the Netherlands, I personally haven't visited it. Maybe I need to take a vacation or find time to take a vacation to go check it out. I think what's cool about it, though, is they're not structural engineers, right? Obviously, structural engineers were involved in the design, but it was a technology company that had this cool new way of doing things, and they needed to showcase it to the world. And fortunately for all of us, right, they picked a bridge, at least for structural engineers. So I think that is maybe a step way into the future. I think we could do that, pedestrian bridges and everything else. Realistically, I'm going to go back to saying, this is a tool in a toolbox. We're extremely efficient at rolling our steel, but there's places where maybe this does start to make sense. And maybe that's connection nodes, replacement for casting, something that's maybe in an existing bridge that needs to be replaced, and a casting may take a long time to get, but additive, they can crank it out in a fairly short order of time.
Okay.
If we want to get much more expressive structures and allow structural engineers to kind of really open their minds to anything they can design and fabricate in terms of a connection, we could probably create it with additive within reason. So I think where I see it coming is, it may be not in my lifetime, we're going to be completely printing structures, right? You grew up watching the Jetsons and they're flying cars.
Right.
We don't have flying cars today.
No,
right?
I thought we'd have them by now.
Yeah, right. You always think we're going to have something like that. So maybe we'll get there someday that the whole structure is 3D printed on site. I think there's going to be intermittent steps to get us there. We're going to probably start creating components. There's going to be challenges and things that we're going to have to work through, and how we gain acceptance for those components, whether it's a node or a bearing or various things that are just really difficult right now to fabricate. The other thing about additive that it affords us is, I think we all know there's the shrinking workforce, and finding skilled labor is getting harder and harder these days, or people that want to go into the trades in general. What additive may provide us is a way to help level the playing field on that, right? So now, instead of one welder welding on a component, we maybe have a welding cell operator or additive cell operator that's running, 3, 4, 5 cells that are working more around the clock. So it may provide us an opportunity to help with that workforce development, and we're kind of starting to see a lacking in terms of skilled operators and tradesmen these days.
Okay. Yeah. Wow. Yeah. That's it's a lot to consider, and like you said, it's not something that's going to happen overnight, or maybe even in our lifetimes. Like, obviously, this is why we do the research, right?
Yeah, we got to start. We got to start somewhere so that we can start bringing it in piecemeal.
Sure.
Certainly.
On that note, are there any other steel-related research projects coming down the pipeline for you, or that you're hoping to tackle in the future? I mean, I know this one's taking up a lot of time right now, I'm sure, but just like looking forward.
Absolutely. I mean, my focus, like you said, right now is pretty heavy on the additive stuff. I'm still trying to stay grounded in our traditional ways that we create steel buildings and steel bridges. We have some interesting work going on right now, looking at weld repairs. So
Okay.
occasionally a weld needs to be repaired. Well, the question is, how many times can you repair that weld before maybe you're getting a decreased performance?
Mm-hmm.
And these things happen in shops. If you talk to fabricators, it occasionally happens. Typically, there's a number that, hey, after 3 times, owners are starting to question. But how do we know that? Is it 3 strikes and you're out? Are we playing baseball, or is it really actually, if you're doing this correctly, can you do a repair weld multiple times? Is there a limit? So we're starting to look at that. That's exciting. One of my colleagues here, Don White at Georgia Tech, and myself have been looking at some stability related limit states. Don was really gracious when I started here to bring me in on some work he had been going on with that. So I've been enjoying learning about that aspect. It wasn't something that I had a ton of experience in before I got to Georgia Tech, but something where Don is definitely one of the experts in the country. So I've been enjoying learning that new end of things. We also have a project coming with Georgia DOT where we're looking to do some fatigue monitoring on some steel bridges in Georgia. Mm-hmm. They just want to know, is there additional life beyond what they're assuming if they just do kind of a traditional calculation, and are they out of remaining fatigue life? We can go out in the field, we can put some sensors on a bridge, take some pretty easy measurements, and in a reasonable amount of time, be able to provide the DOT some actionable knowledge regarding the performance of that structure, and maybe they have a whole lot more fatigue life, and the bridge can last a whole lot longer than maybe they're initially thinking by just doing things, classical calculations. So those are the things I see coming right now. I have background in fatigue and fracture through my graduate work, and looking at how we can kind of continue to improve this idea of redundancy. I hope to kind of stay involved with that too as I continue to move forward with my career.
And just outside of research, I'm curious, what classes are you teaching at Georgia Tech?
So right now I'm teaching Introduction to Structural Engineering, which is a nice one to catch the students and get them headed in the steel direction, right?
Yes.
I do have to talk about all materials, but I don't think it's a secret to any of them that I have a passion for steel. So that one's a fun one. The students are young, and it's a breadth elective. So our students in transportation, our students in materials end up taking it, and it's an opportunity that we can grab those students and get them convinced that structural engineering is the way to go, and civil engineering. The other ones I'm teaching is a behavior of metal structures class. Mm-hmm. It's kind of everything you wanted to know about steel structures. Specifically looks at fatigue and fracture, and then some of the material aspects as well. Obviously, with my passion for additive manufacturing, that's been sprinkled in as sure. Well. I had a similar class at Purdue, and I really enjoyed it. It was one of my favorite ones there. So I've been able to kind of bring that to Georgia Tech.
So yeah, it sounds like, I mean, obviously, you worked under Rob Connor, and he's an expert in fracture and bridge maintenance and everything. And as you said, you're kind of bringing some of the stuff you learned there at Purdue to Georgia Tech. I'm curious, were you involved in any way with the S-Bright facility up there? The sort of, I don't want to call it a bridge graveyard, but let's like where old bridges go to teach people lessons for the future.
That is an awesome facility. I was beyond my point of a research engineer. There was another individual, Jason Lloyd, who kind of taken over.
Jason worked with us for a while, actually.
Exactly. Jason's a great guy. And he was in the role of a research engineer when that was getting going. I was definitely there as a graduate student. And like all good graduate students, you dive into any project that comes available. So I was there during the development. I definitely helped set up a few things. And I definitely did not have the hands-on like Rob or Jason did. But I was fortunate in that I was able to see it kind of come to fruition when they started it, and to help with kind of setting some first initial pieces. But again, more as, I don't want to say labor, but a student out there trying to do something else and broaden their horizons while they're still getting their doctorate.
Yeah, I went and visited it a few years ago, and I was like, this is such a great idea. I feel like every engineering program should have something like this.
Agreed. I haven't been there in a while, and I really want to get back. I was just recently talking to Rob about it, and the pieces they continue to add are phenomenal, and it's a great resource for the industry.
Oh, absolutely. And it's in some ways it's almost like it's like a museum of sorts too, like an outdoor sculpture garden that's also very, very educational and practical.
Agreed.
Well, thank you, Ryan. It's been great talking about your career. I'm just curious if we could talk a little bit about some of your outside interests. What do you like to do when you're not teaching or in a lab? I understand you have 2 young children.
Yeah, I have a 2-year-old and a 5-year-old, and they definitely they consume life. They've been fun. It's been probably a bigger learning experience than going through my PhD, just trying to learn how to be a parent and navigate daily life and getting kids to practice, and even the little things of like, how do you teach someone potty training, right?
Yep.
So I'd say they consume life. We have a dog. My wife, Sarah, and I have got the dog, and then eventually the kids came along too. I don't know if the dog was kind of the training wheels for the kids, but that's where most of my time goes now. Before, I say when I had time, not necessarily before I had kids, when I had more time is probably a nicer way to put it. I did enjoy woodworking. I like doing stuff around the house. Golf. When we lived in Las Vegas for 3 years, when I was at University of Nevada, Las Vegas, we lived on a golf course. Do you know how many times I played that golf course, Jeff?
0.
1. You're close. Well, my wife played at 0, and she was the one I think that grew up around golf more than I did. So I'm hoping to get back into some of those other extracurricular activities once the kids continue to get a little older, and start to get them involved in it too, right? We do a lot of bike rides now and all that stuff. So yeah, the family keeps me busy.
Oh no, yeah, and speaking from experience, my kids are a little older now. Yes, you do start to have more time here and there.
Let's hope.
Yes. And so you've been in Atlanta since around, is it 2019? Is that right?
Correct. Yeah, August 2019.
Sure. So it's long enough to kind of get a feel for a city, but obviously it's a big place, and it takes a while to really get to know a place. But I'm just curious, what have you enjoyed about it so far?
The one thing I never appreciated about Atlanta until I moved here was how big, but yet how small it was. We moved here, and growing up in Appleton is not a big town, and obviously going to school at Houghton is a tiny town. You think of Atlanta being this big major metropolitan area, and it certainly is, right? You can have that experience. But I can be downtown in 15 or 20 minutes in the neighborhood that we live in. Mm-hmm. You wouldn't know that we're in the middle of a giant city. There's big trees, large lots. Everyone is so kind and so friendly around here. Mm-hmm. There's a lot of transplants, and the natives of Atlanta certainly have that southern hospitality, southern charm, and it's been a really, really welcoming community. Even Georgia Tech's campus, right? We're right downtown. Yeah. And other than the fact that you can see the skyline across the highway, you wouldn't know that you're in the middle of a major city. So that's pretty nice, especially coming from someone who went to undergrad up in the Upper Peninsula of Michigan, and I've really enjoyed it. The kindness and openness of everyone around here has been great.
Sure. Yeah. And I have that's good to hear. I've very little experience in Atlanta. I've been there a few times, but I haven't got to get out and explore it much. But the one thing that struck me is how green it was. It seems like there was kind of a canopy over a lot of the city, which was pretty cool.
Yep, absolutely.
And you also don't have to deal with the harsh winters that you would experience in northern Michigan and Wisconsin.
Yeah, you get soft quick. So after we left Indiana, they don't have bad winters, but you definitely get snow and everything else. We went to Vegas, and you got nothing there. Though I will say, in the 3 years we were in Vegas, it did snow once in the city, which was kind of amazing.
Okay.
But you get soft quick. Between Vegas and here, we go home for the holidays or whatnot, and it's nice to go to the snow. It's nice to bring the kids up there and to enjoy the things I did as a kid, sledding and all of that. but it's also nice not to have to shovel your driveway or skate your way to work.
Oh yeah. No, that's I could see that. Yeah, I've lived in Chicago for 20 years now, or a little bit more, and yeah, winter is it's charming for a little while, and then it can be a chore.
Yeah, by February, March, you're kind of ready to start to see that little warmer temperature creep in.
Exactly. Yep. Hey Ryan, I really appreciate your time. Thank you so much for chatting.
It's been an absolute pleasure. I really appreciate you taking the time to do this, and it's been fun to kind of talk through these various aspects of, research, work, and even just general life beyond that.
That wraps up another edition of Modern Steel Construction's Field Notes podcast. Again, our guest this time around has been Georgia Tech professor and 2023 Malek Fellowship recipient Ryan Sherman. And I'm your host, Jeff Weisenberger. Thanks for listening, everyone.